Can you start now? We're good to go? Okay. All right, guys, we're going to go ahead and get started. This is Outlook and Exchange for the bad guys. So if you're in the wrong room, now would be the time. A little starter about myself. My name is Nick Landers. Monox Gas on Twitter is my handle. I'm a security consultant with Silent Break Security. I am with, working the volume there. I'm from Salt Lake City, Utah. I actually grew up in Utah, still live there today. That's where the company's out of. I've been hacking for probably about 8 years, 2 of them professionally. My loves include writing Windows malware. I don't know if any of you guys are familiar with Throwback or Slingshot. Throwback is it's actually public on GitHub. It's a stage 1 persistence tool. And then Slingshot is its counterpart, which is an interactive rat. I do active development on tools that we use internally, or versions of those tools that we use internally. So comparable to something like Cobalt Strike or Meterpreter, but all the code is ours. I love coding with C++, Python, and PowerShell. I might add .NET in there. I just don't get a chance to code in it very often. And I love security research on the red side. So I'm definitely a red teamer. I love to do, the abuse of functionality and essentially writing vulnerabilities that take advantage of Windows environments. And I do enjoy long walks on the beach. So if any of you guys want to swoon me later, you can make that happen. So tonight's agenda, going to go over a quick overview of just sort of Exchange, the way we access it and what it has to offer us. Recon for collecting credentials, usernames, passwords, emails, things like that. Credential harvesting for turning a list of emails or essentially performing attacks to gain email password credentials. And then I'm going to go over an overview of Outlook rules, so inbox rules inside of Outlook. We're going to talk about the exploitation details of using these rules for, remote code execution, persistence, lateral movement, everything like that. I'm going to give you guys a demo, and then we'll take questions. So first to start off is Exchange. Microsoft email product. I can't imagine anybody in the room is not familiar with what Exchange is. The currently supported versions are 2007, 2010, 2013, and 2016. There's quite a lot of variance between all of these versions, but typical Microsoft fashion, they do a pretty good job at supporting all of them. And then Office 365, Outlook.com, those are built on top of Exchange. So pretty much any attack you can perform against an Exchange server, you can perform against Office 365 or an Outlook.com profile. It has a few remote access protocols that we can abuse. One of them is the Exchange Web Services, EWS. It's SOAP over HTTP. Probably one of the most prevalent, especially for newer versions of Exchange. It's used in a lot of applications and particularly on phones like Windows Mobile, things like that. We have Outlook Anywhere, which is sort of the predecessor. It's RPC over HTTP or sub-protocols underneath RPC over HTTP. So like MAPI over RPC over HTTP. So leave it to Microsoft to build you a bunch of abstraction layers. And then in 2013 and up, they actually ditched RPC altogether, and you have straight direct MAPI over HTTP, so Office 365, Outlook.com, and any 2013 and up Exchange servers typically support this protocol. They just pulled RPC right out of the middle, and you could do MAPI directly over HTTP, so that's really neat. And then you have Exchange Activesync, which is a bit of an older protocol. It uses HTTP and XML, and it's typically used for older mobile devices. It's a high latency, low bandwidth network protocol that is very efficient over those, so it's a little bit slower as far as syncing goes, but it's still useful. Some functions or terminology, I should say. We have auto discover, which if anybody's familiar with, you open up Outlook and you type in an email credential and you hit set up my profile, and Outlook somehow finds your Exchange server and builds you a mail profile out of the blue. All you had to provide to it was your email with a domain name and your password. So auto discover is really the basis of this. It's for fast collection of Exchange configurations, supported protocols, and service URLs. So any organization that has an Exchange setup, you can actually go and type in autodiscover.org.com for their DNS name, and it'll oftentimes map you to the server that can give you autodiscover information. So the subpath is actually autodiscover.org.com/autodiscover/autodiscover.xml. A lot of times it's locked with NTLM authentication, but once you provide authentication and you essentially request it in the right way, you can get back a huge XML file that provides you all the information about what the Exchange server supports. So it's really useful, and Microsoft has an online test utility for this. I can't remember what it's Exchange Test Connectivity Runner. It's an old protocol or old application from 2008, but that uses auto discover, and you can actually view the output of it. We have Outlook Web App, which is OWA. I kind of removed it from the remote access protocols because it's not really a protocol we can use to interface with Outlook, but it's super popular. Minimal email client available only on the web. You go to anymail.org.com/OWA and you'll pretty much get to their OWA login page. It's really popular. It's sort of like a minimal Outlook. And then you have a global address list, a GAL, and that's pretty self-explanatory. It just means that users that are using Exchange from outside of the organization who don't have an interface to Active Directory are allowed to pull down a list of all of the emails inside of the organization, contact info. It's sort of like a rudimentary Active Directory sync. So once you can authenticate to Exchange successfully, you can pull down whatever GAL you have access to and store that offline and use it, from further brute forcing. So I'm going to go a little bit into Recon. This is a topic that's covered all over in red teaming and pen testing and network security in general. But it's really important to this attack. This is a credentialed attack, so we need to have email credentials, so a username and password, before we can perform these sort of operations. And I like to talk about performing this attack from the external, which oftentimes involves Recon. So, the goal is to collect emails, usernames, and hopefully passwords from public resources. Sources, the typical ones, search engines, Google, Bing, company websites. You can use all the popular tools, do like DNS brute forcing with a list to find a bunch of subdomains for an org. Public websites, these ones are two of my favorites. LinkedIn is awesome because in the past 3 years, you can pretty much find that every organization out there, all of their employees are tagged to that organization in LinkedIn. So you can do a search for a company and you'll find that, 1,000 employees are linked here, and you click on that link and it pulls you up a search of every single person on LinkedIn who claims that they work for that company or have worked for that company. It's really useful for essentially creating an intelligent list about username emails that we can then brute force against. GitHub is also super great. If you guys have never searched GitHub, it's not indexed in Google, so you go into the GitHub search page and you search org.com in quotes and then like password in quotes or email or @org.com. You can find all sorts of sources. We find that interns post stuff all the time. We constantly have to go to organizations and be like, yeah, there's a configuration file for your SQL server sitting out on GitHub somewhere, so you should probably have a chat with that. We can use database dumps. Those are really popular right now. And then Active Directory. This is solely for internal, but I talk about this attack in a sense of if you have gained network access already and you're trying to bypass network segmentation or the fact that the user doesn't have local admin on the remote box, or you want to make sure that you gain initial access to organization and you're afraid you might lose it. Oftentimes the first thing we do is we go to Active Directory and pull a list of all the active emails from Active Directory and store them offline. That way later, if we need to make more brute forcing attempts, we have the most up-to-date intelligent list possible. So it's really simple. It's an easy piece of information you can pull. Some tooling for this, Lee Baird did the Discover script, or it's like a Kali tool. So it does lots of other things besides Recon, but I'm actually pretty partial to his tool. His script is super awesome. It'll do active and passive discovery, and I don't know if you guys can see that, but it has a list of all of the tools that it actually goes against. It builds you this neat little local website with HTML files that you can go browse around in. For a person just starting off in Recon, I cannot recommend this, more. It's you put in the organization domain name or their name. It does all sorts of company searches and Google searches. The harvester pulls out emails, files, links, everything like that. I use it all the time. Super great for that. FOCA is a tool, I think it was at DEFCON 3 or 4 years ago. I can't remember how long ago, but it's kind of fallen off the map a little bit. It's hard to find a good binary to it, and it's a little sketchy when you use it. It can crash a lot, but that one's also a super useful tool. A guy that works for Silent Break with me, Hans Petrich, actually made a Python script for doing LinkedIn scraping. So he just put it on GitHub for me yesterday. I'll provide a link to it. If you go and download it, you can actually run the script against an organization, and it uses Selenium inside of LinkedIn to pull a list of all the users, their names, and their titles, their job titles. And it doesn't actually click into their profile so that the user doesn't get alerted that you looked at them. And it can go through tons of search pages. And essentially at the end of the day, you get a CSV file of the employees' names, their email, and you sort of have to make a guess on their email structure. Typically it's first name dot last name, first initial last name. But it'll give you a list of their job description, their name, and their assumed email. And we actually use that not only for this attack, but also we do full scope black box pen tests. So, we send in targeted phishing emails with macros, OLE documents, things like that. It's super awesome for getting targets because you just pull through a huge Excel document and you go, I think I want to target all of these HR people or all of these people from, their customer service department, whatever it may be. And then Hacker Target, that's a neat site, also really good for beginners. They have a lot of neat APIs for doing like DNS lookups and subdomain brute forcing, things like that. It's really cool. So now I'm going to move a little bit more into active. So there's collecting, let's say that, we used LinkedIn and this is a common tactic for us. We pull a list of a bunch of emails that belong to the organization, let's say 1,000. And they're assumed emails, but we don't have passwords for those emails yet. So what we want to do is we want to collect passwords for those as well, and brute forcing is an awesome way to do that. The guys from Black Hill Security actually wrote password spraying against OWA before I even built this attack, and it's super awesome. They use burp with OWA, and essentially they iterate through with like a common password like summer 2016, and they brute force like all of these 6-character usernames until they find email credentials. EWS, Shell Intel has a PowerShell toolkit called OWA toolkit that I absolutely love. It's a couple of PowerShell commandlets built for interfacing with EWS, and like it can do brute forcing against EWS. I actually have a screenshot included there of like what that commandlet would look like. So it just says brute EWS. You supply it EWS service URL, like a SOAP URL, and it'll try every single user with like a basic password. Summer 2016, password 1, spring 2016. Those are all awesome candidates. And you'll find that when you have 1,000 emails to try, and you try the really stupid password, all you need is one account. So of those 1,000 emails, you might get, less than 5 people that have that dumb password, but it gives you an initial access vector into the network. And then for NTLM HTTP auth, I've run into some situations where I needed to do just like raw HTTP NTLM auth brute forcing. Burp does not do this as far as I'm aware. So I just used the request library inside of Python. There's a GitHub page for an NTLM addition plugin for that. And I just scripted it out inside of Python to push against that too. This is kind of part 2 to collecting credentials. On top of brute forcing, I also love to do credential harvesting attacks via email, so a lot like phishing emails. My favorite is to impersonate the company's login page, like Office 365, OWA. You go make a phishing site with a similar domain name, looks the exact same. Send the user an email saying their mailbox is filled up and we just expanded the space and they need to log in to make sure that they still have access to their email. And you'd be surprised how many people freak out about that and go log in. One of the better things about this is there's no payload to burn, and we blend in with spam. So when we're doing targeted attacks with like phishing documents and like Office macros, we might only send 10 to 20 attacks in an organization or to an organization, because if our Word document gets caught, we oftentimes have a lot of IP invested in that macro. We've built a really badass macro that can do all sorts of detection and sandbox detection and bypassing, things like that. And we really don't want that compromised, so we keep it small. Versus a credential harvesting campaign where you're trying to get somebody to click on a website and put in their credentials, that's so much more common with spam. So we can send 200 emails, which gives us a much higher likelihood that at least one user will open the attack. I've also used external site compromise as another method. So WordPress, Live Agent, you have these companies that are outsourcing some of their public-facing websites to other companies. So you go find a vuln in their WordPress site, you pop their box, and then you find out that server isn't actually inside of your target organization's network, and you go, oh, shit, I popped a WordPress box for nothing, and you go bail. Now that's no longer needed, and we can do things like backdooring login pages, doing social engineering from that site, and we can also grab password hashes from database, and then do credential reuse to their internal email, because a lot of times people use the same password for their WordPress site as they would for their internal email if they're like a web admin or something like that. So now I'm going to get into the Outlook rules a little bit and just kind of go over an overview. You can see Microsoft's official terminology on what an Outlook rule is. Really what I focus on is the fact that a rule comes in 2 parts. It comes with a trigger and an action, and there can be multiple triggers defined and multiple actions defined, but those are sort of the 2 pieces of an Outlook rule. Triggers are pretty common, self-explanatory. It's anything from receiving an email with a specific subject, from a specific person, anything along those lines. Rules can be created both server-side and client-side, so Microsoft actually added the ability to make Outlook rules on like OWA or Outlook.com. And they can also be built client-side, which is kind of the original way they were designed. And if the rules aren't necessarily compatible, in fact, like if you build a bunch of rules out of the raw Outlook client or the normal Outlook client, go into OWA and then try to add inbox rules there, it'll actually warn you and it'll say, hey, like you already have rules from Outlook added. If you add these rules on the OWA side, they're going to destroy your Outlook rules. They're not quite compatible, so just keep that in mind in your attacks. There's 2 actions. There's the actions part of the rule split into 2 sides. There's server-side actions and client-side actions. So, when you define an action like when I receive a message from this person, I want to mark it as important or move it to a folder. Those are all actions that the Exchange server can take. So it doesn't bother asking Outlook to do it, because that would just be I'll ask you and you come back to me and tell me what to do. So the server-side rules get processed immediately on the server. And then for any rule that is based in the Outlook client, so playing a sound, printing a message, executing an application, those are all executed client-side. And what happens is there's a hidden folder inside of everybody's mail profile called the deferred action folder. And when the server side wants the client side to perform the actions associated with the rule, it actually puts a deferred action message in that folder. And the client then syncs it down. Outlook looks in that hidden folder, will look at that message. It has a rule ID associated with it. It'll go look up that rule locally and execute the actions associated with it. So the server is actually supplying a message to let Outlook know that it needs to execute rules. I'd love to look at ways to forge these rules in the future, but I haven't had a chance yet. And then, of course, rules are stored on the Exchange server, and they're synced to all Outlook profiles, which is actually sort of the basis of this attack. If I have 4 Outlook profiles set up on 4 different boxes, and I build a rule on one, it'll hit the Exchange server and then get synced down to all of my Outlook profiles, so they can all process the rule as well. Even if that rule is built as a client-side only rule, so even if the only actions associated with that rules are ones I want to apply on my computer, they'll still get synced to other machines. So when I first started looking at this, if you go into Outlook, you can actually, build a rule. And when I got to the actions portion, there's a lot of interesting stuff in here. Most of them are for typical Exchange actions, like, forward the message, mark it as important, things like that. And then you get into some of the interesting ones. Print it, play a sound, start an application, run a script. And these seemed really interesting to me, especially start an application and run a script. I'll be focusing on start an application because that's where this exploit comes from. But run a script is also a really neat action. It will, if you go into Outlook and you enable the developer tab and actually go in, you can build VB macros that sit associated with your Outlook profile. And in run a script, you can have it run local macros inside of Outlook. The problem is these macros aren't synced through the Exchange server like the rule is. So for our purposes of gaining initial access, it's not as useful. For persistence, it could be, and I'd love to see somebody look at that as like a tooling mechanism. It's super stealthy. You would put a macro inside of their Outlook profile, and then when a message is received, it'll trigger that macro script and run it inside of Outlook. So I wanted to look inside of the start application function. So I just built a rule here, and when you click start an application, it has you supply an application name. It opens up File Explorer. You go and browse to whatever file on your system that you want to run, and you click yes. And by default, it limits you to exe files, but you can just do that trick where you change the exe dropdown to all files and pick whatever you want. So I built this rule, and inside of Outlook, you can go to the rule menu, go to options, and then hit export, and you can export all of your rules to individual files. So I popped open these files in a hex editor because I wanted to see what these files look like at its core, and I started looking at, I could see the name of the rule, this fun rule, and the path down there, the test.txt. So clearly these offline rule files are supplying this information. So they could be messed with there. I also took a deeper look. I wanted to know what Windows APIs Outlook was executing when we told it to execute a rule. So when I built a rule that executed cmd.exe, what actually happens in the backend when Outlook calls cmd.exe? Because what I really wanted to do was get argument parameters. That's still my main goal with this, and it's something I really want. I'll talk about that in the exploitation challenges. You can see there I've actually hooked to Outlook.com, and I just took a guess at all the APIs it would call. It actually ends up calling shell execute exw, which is the wide version of shell execute, the extended wide version of the original function shell execute. And the module that's calling is actually mso.dll. This is a shared library amongst all Office applications. It's in the program data directory inside program files. And then you can see that I looked at the details of this function. The verb is null. I'll go into this in the next slide. The file is set to, cmd.exe, and then the parameters is null. So, and you can actually go in there and you can look at the shell execute has tons of parameters for setting icons or hiding the window. It has a lot of functions like that, so you can see exactly what Outlook is doing when it's calling this. This is a quick look at shell execute ex. It takes this structure called a shell execute info structure. This structure has a bunch of different properties in it. I've kind of ripped out the ones that I find interesting. LP verb is kind of one of the most important. And it's essentially really associated with Explorer and mouse clicking. So when you're kind of browsing around your file system in Explorer and you right-click on a file and it brings up all of the things you can do with it, print, open, save, run as, all these things, those are associated with verbs most of the time inside of the registry. So Microsoft has built this, I would call it a platform where applications can associate different actions with ways to call their program. So a text file might be opened with Notepad, or it might be opened with Atom or Sublime, depending on what you use. And when you changing your default program, what you're actually doing is changing the open verb for the text file. You're going into the registry into that HKey class's root, and you're setting it so text files are now opened with the command string Sublime text file name or Atom text file name instead of Notepad text file name. So this is sort of the core that Windows is built off of when you're like interacting with the desktop and opening up applications and files. So it takes two more parameters. One of them is a file, which is pretty self-explanatory, and then the parameters, that allows you to provide arguments to the file. And like I said, Outlook, the MSO DLL just sets this property to null. I haven't gotten a way to like overflow into this property. I'd love to figure out how. But this parameters is always null. So really what you end up with is when you tell Outlook that you want it to execute an application, it's you go to Explorer and double click on it. That's the action you have. So your payload has to be able to execute maliciously when you just double click on a file. I'm going to go into the exploitation challenges that, as my mind started thinking about this, I was like, okay, let's actually make an attack out of this. Now, what do we have? So we require valid account credentials along with Exchange service access. So, we need to have a valid email and password. We can get that through Recon, brute forcing, like the slides I mentioned earlier, and through many other means. It's actually a cool attack if you find yourself in a position where you have somebody's email and password, and you're like, how do I get on their box? This would be a perfect reason to use that. And then we need some sort of service access to Exchange. So RPC, MAPI over HTTP, any of those services that we can interface with the Exchange server from the external. We don't have command line arguments, so we have to make it so that our file as a package will execute our payload when we double click on it, or when we call shell execute with an open verb, which would be the more technical way to do it. And then we need a local file on the disk for Outlook to open it. So when Outlook actually receives this trigger, shell execute is going to try to go find this file so it can run this verb on it. And this is really where UNC comes to the rescue. This is like one of the larger pieces of this attack. Whenever you go, whack server name, whack share, Windows supports that path. Like you can go into dir and then type in a remote file system. And when you do that, Windows has a fallback mechanism that it goes through for protocols. So at the top, it'll try, SMB, and it'll fall through all of these different like RPC file management protocols until it gets to the very end. And the last thing Windows will try is to try to open a WebDAV to that address. And WebDAV is a protocol built on top of HTTP that Microsoft introduced to allow file sharing. So essentially you can access, manage, control, delete files over HTTP calls. And by default, when you do this inside of Windows, it is proxy aware. So actually, if they have like a system proxy set up and you go to a UNC path, it'll use the proxy when accessing that HTTP address, which is super useful. It's becoming a really popular thing to make proxy aware tools. In this case, it's like Reg Server 30. Windows does it for us. We don't even need to try. So the two instances I looked at building this were a local Samba share. So inside of Kali, you can set up a local file share and host files. And that's really where I found a lot of utility in internal pen testing and pivoting. So you get a rogue device on the network, you're doing responder spoofing, you get somebody's credentials, but then you go try to access their machine and they're not a local admin. So you have domain credentials, but you're still on your own box in the network. If you wanted to pivot to somebody's machine, you spin up a local Samba server on your Kali box and perform this attack and have the user access the file off of your Kali VM. So they don't ever reach outside of the firewall. The next one is a WebDAV share, and that's accessible via UNC path. Like I said, HTTP with proxy awareness, and the machine will actually reach out to the internet to get this file. So if we supply a public IP, if we supply a domain name that resolves to a public IP, the Windows box will actually reach to that public server over port 80 and try to access it over the WebDAV protocol. We need a file type that can give us local code execution with shell execute. This is, talked about a lot: BAT, EXE, PIFs, VBSs, HTAs, LNKs. Any file where we double click on it, we can get some sort of arbitrary action with it. And then the target needs to have Outlook open. That's hopefully one of the simplest requirements for this attack. A lot of people just, business people have Outlook open all the time. But we have had instances where we try and attack at 8 o'clock in the morning, it doesn't work. We come back 6 hours later and it does because they opened Outlook sometime between in the morning and in the afternoon. I want to talk a little bit about use cases for this attack. So my favorite is initial access to a target network. It's relatively easy to collect email credentials, and we can use it to convert those credentials into internal network access. So no more payloads, no more Office documents, no more OLAs, no more getting them to click on an HTA and click run. We just need them to give us their email credentials. Go to a coffee shop and spoof their box while they're sitting there and get their creds. We don't even really have to worry about what their machine is, or what the user is trained to do in regards to like opening up a payload. We just need their email credentials. We can pivot to a machine without local admin privileges. This is one of my favorite uses for this. We've actually had situations where I've gotten creds through Responder, broken the hash, and I wanted to get on their workstation. Normally you need administrative access to access, Service Control Manager, WMI, do SCH task at, whatever it is, PS exec. This, we don't need it. We just get their credentials and we go out through Exchange and make their box reach out and grab our file from us. So we don't have to interact with the Windows services locally. We can bypass network segmentation in the same way. If you're sitting on an HR box and they're locked down from accessing IT, but you have IT administrator credentials, use those and make the IT workstation reach out and grab your payload for you. And then persistence, this is like that's one I haven't done a whole lot of work with, but I love the thought process of it. It's ridiculously stealthy. It's a very obscure technique with minimal tooling on both sides for both performing the attack and detecting it. So no defender's ever going to look for it. Well, hopefully all you guys will now. You're going to walk out of this room going, oh my God, I need to go look at my Outlook rules. call your SOC up, like pull open all the rules, make sure there's nothing there. It's really long term. Because the rule is linked to an Outlook or an email profile and not a workstation, we can persist across an IR wipe. So I'll talk about a case study at the end where we had access to a box. We built a rule to get access to that box. They found out that we were on the machine. They wiped it completely, had the user reset his password, moved him to a new machine. The user set up his Outlook profile again, and guess what? Exchange was like, hey, by the way, you need this rule, so just go ahead and have that. And then we sent him an email the next Monday from an external account, and boom, we pop a shell. It's super crazy how stealthy and long-term this is. In the same sense, we can drop an executable on an internal file share. So for really stealthy persistence, you get inside of a network, you go find their most common public file share on their domain controller, drop an executable file on it, set up the malicious Outlook rule on either one or many profiles. You can set up on like 20 emails. You get out of the network, then 2 years later you come back, you send an email externally to any one of those 20 people, and their box will reach inside and grab that exe off the file share, because everybody knows those things. I still see files from like 98 sitting on file shares. It's crazy. Nobody'd ever delete it. You name it something important like, budget 2016 do not delete, and nobody's going to touch that thing. So here's sort of a state of things. Just the start of this month, a couple of really awesome people released 2 tools to interface with this project. Originally, I had built this rules.py script, which just builds malicious RWZ files for importing into Outlook. So I sort of reverse engineered the file protocol for those Outlook those Outlook rule files, and built a Python script that'll generate rules for you. So you don't have to really interface with Outlook for the rule generation. You build the file offline and it gives you a little file you can tell Outlook to import, and suddenly you have your rule and it syncs to Exchange. Ruler is a MAPI over HTTP, uses MAPI over HTTP to quickly sync rule files without building the complete mail profile. So this is something I've been wanting to build for a while. SensePost did it. Super awesome. It will just interface directly with MAPI over HTTP to sync the rule. So all you have to supply it is user credentials, and suddenly that user profile has your rule synced to it. The only downside to this, as far as I'm aware right now, it only supports MAPI over HTTP, which means that it's only Exchange 2013 and up, and Office 365 and Outlook.com. I'd love to make, or someone else to make, a port of it that does MAPI over RPC over HTTP. That way we can support all of Exchange. But it's a super awesome tool, and I highly recommend looking at it if you want to understand how rules are synced over MAPI. They did a lot of good research on it. And then MRW Labs built the XRules tool, and that uses local Outlook profiles to import malicious rules for persistence. So you get a code execution on a box, you want to persist on that box, they built exe that you can inject into memory. It will go and look on disk, pull all the MAPI profiles off of disk, and sync the rule that way. And I love those 2 tools and how they came to like similar tooling from different positions. SensePost was working from the outside, trying to gain initial access, and XRules is sort of I already have access to a box, but I'm really worried that it's going to get wiped every day, and I want to have persistence in another method. So I believe they used it in a VDI environment, which is really neat. I'm going to go ahead. I actually recorded a demo for you guys because it's kind of a complicated one. Can you guys see that all right? It's like the resolution all right? All right, so in this case, I have my local workstation, which is like my attack workstation, and I have a VM running, which is like my target workstation. All it has is Outlook open. There's no other programs open. It's synced to, a mail account, and I believe it's called DarkSide Dev, which if any of you guys are taking a Black Ops course, you'll know what that machine is. So I've set up a public Ubuntu server, and I'm actually SSH'd into it right now. So I have WebDAV configured on this server. So this Ubuntu server is serving files over WebDAV. It's really easy to set up WebDAV in Apache. It's just like one configuration change. I actually list out the directory in the web dev just to show that it's empty. And then my custom tool of choice for my wrap will be Empire. So I'm actually going to use Empire on the same server to get a shell back. And that's just so I can actually use Empire to write like a bat launcher directly to disk. So I already have a stager set up under Derby. It's just going to call back over port 8080. I think ideally you'd probably want to use these on different servers so you could do true HTTP comms both ways. So I set up a bat launcher and I just set the out file to the Apache directory where the web dev server is configured. And I just tell it to set the auto delete defaults because I want this file to persist. And then I tell it to generate. You can see down the bottom I refresh and suddenly Windows can see that evil.bat sitting in that web share. So it's actually calling out over HTTP to my web dev server externally and it's loading it up in File Explorer like it's a local file share. It's pretty crazy. I pull up in the bat file just to show you the PowerShell one-liner that Empire puts in there for the launcher. So now that I have a payload sitting on a web dev server, I need to build the Outlook rule. I'm just going to use my rules tool. I'm sure I could have used sense post tool for this, but I kind of wanted to do my homegrown stuff just because I like it. I set the rule name to DerbyCon. It asked me for a subject trigger word, so I just provide shells. So, when the word shells is received, it'll trigger. And then the file path I wanted to execute is off of that web dev share, evil.bat. So it actually builds me an RWZ file on disk, and this is just the offline version of that rule file. So I'm going to go ahead and open Outlook here. So on my attacker machine, in this instance, I've synced my target's Outlook profile to my machine. So I've gone into Outlook, say, add a new profile, provided their email and password, and it's built me a local Outlook instance for my target user. So there's actually 2 Outlook sessions existing, one on my attacker box and one on the target box. And I'm just going to use my local attacker instance to actually sync the rule to Exchange. This is where the MAPI over HTTP comes in. So I pull up in the rules panel, I hit options, import rule, and then I'm just going to supply it the path of that RWZ file that I built. So at this point, Outlook is going to read in my malicious rule, it's going to sync it up to Exchange, and it's going to supply it down to my target Outlook instance. So that target instance of Outlook running in that VM just got this Outlook rule without me ever doing anything to it. You just had Outlook open and Exchange was like, oh, here you go, have this malicious file that some attacker just synced in. So there's a couple different ways to trigger. There's lots of different ways to trigger the rule. My personal favorite is to set up a subject trigger and then send the user an email from themselves. It's hard to track, and if the user ever finds it in their inbox or their deleted items, they just go, oh, it was from myself, and you just name the subject line like Outlook updates or like some weird hex error, and I think most users will blow it off. So in this case, I'm just setting the to address to the user themselves and doing pop shells in the subject, and I'm just telling them, don't go to DerbyCon, they'll pop shells on your box. This is from future Dan. So I go ahead and hit send here, and then after the message sends in Outlook, I just close my local instance. That's so that my local instance and their local instance don't interfere with each other. Like if my instance gets the DOM, then it might execute the attack instead of the remote one. So after the email sends, I just close out of my instance and wait for the email to be delivered on target. Actually, I get a little bit impatient here, and I hit like send and receive, and I'm about to restart Outlook. I'm like, God, email, come in faster. And then right there, it popped. So there's ways to do this without a window popping. My favorite is bat to exe with an individual option switch. I actually have this documented in the blog. You can see right there in Empire, I just got a new agent back on my remote machine, and it's on the dark side dev machine. I'm going to interact with it and then run a PS just to prove I'm not fooling you guys. So that was completely external to remote code execution on a host using only Outlook. That target only ever had Outlook open, and all they had to do was receive an email. So this is kind of case study number 1. I want to go over a couple of legitimate use cases that we've done for this attack. In the last 6 months, I've used this on 7 different engagements. This attack is super useful, and it is legitimate. I don't do this out of research for, oh, hey, this is cool, I'll give a presentation on it. Like, I built this because I wanted to use it in engagements, and it has worked out beautifully and so many times. So the first one was a black box, full scope black box pen test for an org. I discovered a 0-day in the Live Agent software, so it's a support chat software that was externally hosted. I compromised their SQL database and used tokens to log into the web interface for the application. And then I placed custom HTML on the footer of the login page to steal user credentials when people logged into this Live Agent app. So the Live Agent server was externally hosted, wasn't in their network, but all I wanted was creds. So I left that running for about a week, and over time I found somebody who had the same password set for both this Live Agent program and their internal email, used the Outlook attack to pop their network, and then lateral movement and privilege escalation to domain admin. So that was compromise of a third-party application that wasn't even in their network to domain admin using this attack in the middle. Another one was another black box pen test for an org. We used Credential brute forcing to find a weak user login. So I collected a whole bunch of target emails, brute forced against them to find a user who had like summer 2016 as their password, used Outlook access to pop their box, and then again, lateral movement of privilege escalation to domain admin. And in the middle, I actually put that their security team discovered the compromise. They told the user to shut down his box. He came back into the office. They reset his password, blew away his machine, actually moved him to an entirely new computer. The next Monday, I shoot an external email and pop his box again, and we're back to business inside of their network. So that was a good example of how the persistence technique can be used to persist across IR wipes. So like I said, phishing payloads are dead, guys. You might as well just toss all your macro payloads out the door, VBSs, OLAs, start getting on this Outlook train. I need stickers. I feel like the ATD guys could hook me up with stickers. Order like 10,000, and then we'll stand at like 1,000. So I kind of want to talk a little bit about what now. I mean, I explained this attack. I explained its different usage. Future research, I'm a red teamer mindset. So like my ideas for this tool are like, oh, what are all the cool different things that you can do with Outlook rules? One of them is to abuse the MSO DLL or Outlook to avoid argument limitations with shell execute. So if you actually, I actually threw the MSO DLL inside of IDA and like looked at the exporter function to how it was executing shell execute. Went through it a little bit, didn't get very far with it, but if you could find some way to like overflow in the rule to get command line arguments, or potentially abuse the verbs in the registry, I built a Python script to enumerate all the verbs out of the H key classes root, and look to see if there was any weird file extension that I could use where it would like pass my file name as an argument as well to get like arbitrary command execution. Modify the ruler by sense post to include support for MAPI over RPC over HTTP, just so we can get the 2007-2010 support. Build past the hash support into the tooling, so NTLM hashes could be used to pivot internally. I did a proof of concept of this with Python, and I actually used the Python NTLM request library and modified it so it could do past the hash. So if we have an NTLM hash for a user, we could actually pass that to the Exchange server, get access to their mailbox, and then sync rules to it. So another Lee Christensen had the idea of doing an SMB relay, but to the Exchange server. So normally you do an SMB relay attack, and you have to be local admin on whatever remote box you're relaying to. Not anymore. You could relay to the Exchange server, open up a session, and then sync a rule to that profile and gain code execution that way. You could use named pipes as a file replacement, so you could do in-memory pivoting. So if you were on a box and you wanted to get to another box, you like load up the file as a named pipe, supply it as an argument for the rule, and then get the remote system to read that file or that named pipe like it was a file, and supply like a bat over it, whatever, just so that you didn't have to write out to disk anywhere. I'm a fan of existing in memory. That's what my tools do. And then I thought about this recently. You could potentially backdoor or patch the MSO DLL on disk for like stealthy Outlook persistence that didn't include a rule file. So if you got access to a host, you could like patch their MSO DLL so that anytime an email was received and it like checked to see the actions of a rule, you like injected your code in there and was like, hey, if it's, past 12:30 on a Wednesday, I want you to execute this batch file over here. So, really, really neat stuff with that. As far as defenses for this go, we do collaborative engagements with organizations, and our constant recommendation is just to disable WebDAV outbound on the firewall. So I'd say a lot of providers support this. I know Palo Alto's do by default, but you can just stop your clients from reaching out over HTTP with WebDAV protocols. That's probably the easiest defense. On another hand, do the host-based approach where you monitor process creation for Outlook and or app whitelisting. So, if you have app whitelisting turned on or app locker, I'm not going to be able to reach to a WebDAV share and just execute a random exe or a bat file off of that WebDAV share. So there is host-based solutions to do this. Matt Graver is going to be a great resource for that. And then we can monitor Exchange logs for rule sync events from outside of the network. And I put a question mark after that because I haven't had a lot of time to research the defenses on the Exchange server side. But I imagine if we had enough auditing enabled, we could watch this rule activity occurring against an account and create alerts on the logs, and or just go out and watch or check all of the rules against all of the profiles. So I want to leave some time if anybody has any questions from this research. Thoughts on that? Yeah, what's up? Okay. All right, okay, so just so everyone heard, he just asked if I've ever encountered legitimate usage of this feature inside of Outlook. Me, myself, probably not, but when I talked to Microsoft about this, they didn't seem too keen on the idea of blowing away the feature. I imagine a lot of people use it for, like when they receive an email from their boss, they start up Reddit or YouTube or something. Like, I don't know if that's considered legitimate, but like, I don't know, like, it adds a lot of cool, and you can actually, I should mention, you can do the same thing with HTML files, or websites for that matter. So if you supply a website string to the rule, it'll pop open your default browser and go to that website. So you can get Outlook to like pop websites when you receive emails instead of applications. It's kind of neat. What was your question? Mm-hmm. Oh, okay. Okay, so that's an interesting question, and one that is like a constant ongoing, like I would say within the past month I've had conversations about this. I've seen some organizations lock down two-factor on OWA. So when you go to the Outlook web access, you have to supply a token before you can finish logging in. That wouldn't stop a lot of these attacks just because the two-factor auth doesn't apply against EWS or the NTLM auth on the auto-discover page. So a lot of the times, like the two-factor authentication will be applied to the OWA like the login page. So when you're doing the login with OWA, you've already accessed the site and brought it up. Whereas if you go to like the auto-discover XML file for an org, you have to supply HTTP NTLM auth before you can even view that file, which means that you can do brute forcing against the HTTP NTLM auth in the same way that you would do like basic brute forcing against an old firewall. And I'm not sure the specifics of the other protocols or like Office 365 if you have it enabled there. I believe you could, because the two-factor auth is only going to apply after you've got the successful credentials, which means that you can get to the Office 365 login page fine, and you can try credentials. The minute you see a different response, which is probably the next page where it like loads that up, you know you have valid creds, and then you could probably use a different exchange protocol like EWS or MAPI over HTTP to access it directly. I haven't verified that, so I'd love to do research on it because they might apply that two-factor auth to different protocols. Yeah, for sure. Yeah, I'm not sure. It's just one of those things where I want more research to be done into it because I'd love two-factor auth. I'm a huge fan of multi-factor auth, and I want it to be a mitigation for this attack. But just knowing the way Microsoft and their protocols work, the very fact that you have like 6 different ways to interface with an Exchange server means that the two-factor auth probably isn't applied to all of them, and particularly not the low-level ones. If you want to know for sure, I'd highly recommend you try it's not for sure, but if you want to like get a better idea, pop open a brand new Outlook instance and try to build somebody's profile remotely. If you get any sort of two-factor auth there, then I'll be a lot more confident that it's going to stop this sort of attack. But if you just have two-factor auth on like OWA or the Office 365 online login pages, I'm kind of iffy about whether that would stop this attack. So, does anybody have any other questions? Yeah. I haven't. That sounds cool. And I actually thought about that. Once you had like domain admin on the network, if you could get into an account that had admin over all the exchange, like the exchange admins group, then you could like add rules to each individual person and like trigger them globally and pop shells all over the place, like mail slots or something like that. I really want to encourage you guys, please go research this technique. I talk about it and I have so many things in my mind where I'm like, wow, I want to go try that. But to answer your question, no, I haven't really looked at it yet. Somebody else have a question? Yeah? So there's actually ways to disable the supported protocols in Exchange. So you can like disable MAPI over HTTP or RPC over HTTP. And then in the Exchange or in the auto-discover file, you'll actually see that reflected. So like SensePost tool actually checks for this. It looks at the auto-discover file, checks to see whether the MAPI over HTTP has a service URL supplied. And if it does, then it'll continue with the attack. Otherwise, it just gives up. So it's tough because at some point, a lot of organizations need to supply a user with like external access to their email via Exchange. And so it's really hard to turn those things off, and I think that functionality gets even, I'd say harder to turn off when you get into like Office 365. Like, you're going to talk to Microsoft, and I'm going to be like, yeah, we can't just like disable this one core protocol for all your clients. But I recommend looking into it. If you let me know, hit me up on Twitter, send me an email. I'd really love to spread out this research. Does anybody else have any questions? No? We're good. All right, I'll close it out there. You guys have time to get to your next talk. Come up and talk to me, say hi, but that's it.